Today we are going to discuss about the maximum point, minimum point, inflection point and the saddle points. So basically, as you can see, what is a minimum point? This point can be termed as a minimum point. Okay, this point can be termed as a maximum point. This point also can be termed as a minimum point. Okay, now this is a local minimum and this is a global minimum, because in the entire graph, if we try to terminate that, this is the actually the minimum point. So this is the global minimum and this is the local minimum, and this is the maximum point here. But as you can see, this maximum point is the global maximum point, or it is the global maxima, it is the local maxima. Now if we talk about the inflection point, what is the inflection point? As you can see, this graph is concave down. This graph is concave down. If I tell from this perspective or from this part of the curve, then this part of the curve is concave down. But at this point, as if I just mark this point, in this point this curve is, after this point the curve is being concave up. So this point is basically, from this point the curve is changing its curvature. The curve is converting from being concave down to concave up, because before this point the curve was concave down, and after this point, as you can see, the curve is concave up, right? So that's why we can say this type of points where the curves changes its curvature from concave up to concave down, or from concave down to concave up, can be termed as inflection point. So this point is basically our inflection point, which is denoted here. Okay, now from it can be also termed as, if the curve changes its curvature from being concave up to concave down, then that can be also termed as inflection point, which can be shown here if I extend this figure, but I am not extending it anymore. I hope the idea of minimum and maximum point and inflection point is clear. Now we have to find out the stationary values of this function x cube plus 3xy square minus 15x square minus 15y square plus 72. And after finding the stationary values, we will also try to look whether the stationary values are giving us maximum or minimum or saddle point, or neither maxima nor minima. So basically we have to find out the value of rt minus s square. What is r, what is t and what is s, that I am going to tell in the later part of the video. That is very easy concept, you will easily understand it. If rt minus s square is greater than 0, then and r and t both are negative, then our stationary values are giving us maximum. If rt minus s square is positive and both r and t are also positive, then our stationary values are giving us minimum point. Or if rt minus s square is negative, then we are getting the saddle point. In that particular case, r is positive and t is negative, or r is negative, t is positive, that type of situations will arise. And if rt minus s square is nothing but equals to 0, then we are not getting maxima, or we are not also getting the minima. Let's go into the numerical part. So this is the function. At first we will do nothing but we will derivative. We will find the derivative of the function with respect to x, and we will term it as fx. This is our fx. If we do the derivative, x cube will be converted at 3x square, 3xy square. If we do the derivative, we will get 3y square only, and we will do the derivative of x, which will come out as 1. So we will have 3y square. If we do the derivative of minus 15x square, we will get minus 30x, and the 15y square will not have any derivative because x is not present in the term. And if we do the derivative of 72x, then we will get the value of 72. Then we will do the derivative again. This f of x, we will do the double derivative of it. That means we will again do the derivative of this function, and we will term it as fxx. So if we do the derivative of this function again, then we will get 6x from here, and from here we will get 0, from here we will get minus 30, from here we will get 0, right? So that is what we have obtained, 6x minus 30. Then we will take the function again, function of xi, and we will do the derivative with respect to y. okay, and we will get minus 6xy minus 30y, and then we will do double derivative of it. We will do the derivative again by y or with respect to y, so we will get 6x minus 30. Here you will get 6x, and here you will get minus 30. Now whatever we have obtained in the fx, that is when we have done the partial derivative of function of xy with respect to x, whatever we have obtained here, we will do the derivative of this function with respect to y. Okay, let me erase it at first. Okay, now if we do the partial derivative of this function with respect to y, what will we get? So I am just doing the partial derivative of this fx with respect to y, and I will term it as fxy. First is denoting that at first it was the function was taken, and then the function was done a derivative with respect to y x, and then the function is again gone through a derivative with respect to y. Okay, so in that case you will just get the value of this is the only term which will have the derivative, and this will be 6y. Okay, similarly we have obtained fy also, and we will do the derivative of this fy with respect to x. That means at first we have done the partial derivative of the function with respect to y, and we have obtained this, and we will do the partial derivative of this with respect to x again. Okay, so we will do the partial derivative of it with respect to x. So as you can see, I feel I have done it or not. Function of y x is also supposed to be done. Let me do it here. So what will we obtain if we do the fyx? That is, at first we will do the derivative with respect to y, and we have obtained this, and then we are going to do the derivative with respect to x again. So if we do the derivative with respect to x again, we are going to get 6y, right? Because this x will have the derivative of 1, and we will get 6y, and this part will be gone, and this part will be 0, so we will get 6y. So function of yx is nothing but 6y also. So both of fxy and fyx are nothing but 6y. Now in the second step we are going to set function fx equals to 0 and fy equals to 0. So fx equals to 0 and fy equals to 0, as you can see. Now from the second equation, if we take 6y common, okay, we will get x minus 5 equals to 0, and if the products are equal to 0, 6y into x minus 5 are equal to 0, then it is possible that 6y equals to 0 or x minus 5 equals to 0. Otherwise the product will not be equal to 0. So in the first case y is coming out to be 0, and in the second case x is coming out to be 5. Now how to find out the maxima and minima? For that we are going to step 3. So in the equation 1 we are going to put the value of y equals to 0. So basically these two values are basically the values of y, right? These two values are basically the values of y and x. So at first we are going to put y equals to 0 in the first equation. This is our first equation. So if we put y equals to 0 in this equation, then this term will be vanished, and we will have only 3x square minus 30x plus 72 equals to 0. Okay, so as you can see, this is present here. Yes, 3x square minus 30x plus 72 equals to 0. We are dividing the entire equation by 3 on the both the sides, and we are getting it as x square minus 10x plus 24 equals to 0. We are doing middle term, and we are getting the value of x. Here we are getting two values of x, 6 and 4. Now what are our stationary points here? So our stationary points are 6, 0 and 4, 0. How can I say that? The value of x is 6 and the value of x is also 4. For which value of y? The value of x is 6 and 4 for which value of y? Obviously we have put y equals to 0 in equation 1, and by putting y equals to 0 in equation 1 we are getting the two values of x, 6 and 4, right? So the value of x is 6 and 4 for which values of y? For value of y which is equal to 0. So these two stationary points are 6, 0 and 4, 0. Similarly there was another thing which was obtained in the first order in the second step, that was x equals to 5. Now if we put x equals to 5 in the equation, suppose this is x equals to 5. If we put the x equals to 5 in equation 1, at first what we have done, at first we have put y equals to 0 in equation 1, right, and we have obtained this y equals to 0 was put in the equation 1. At first we have done this, and now we are going to put x equals to 5 into equation 1. Here by putting y equals to 0 into equation 1, we have obtained two stationary points, and by putting x equals to 5 into equation 1, let's see what happens. By putting x equals to 5 in equation 1, we are getting 3 into 25 plus 3y square minus 30 into 5 plus 72. Here we are also getting two values of y. One is 1 and another one is minus 1. Right, so basically here y square is coming out to be 1, and as y square is equal to coming out to be 1, so y can be plus 1 and y can be minus 1 also. So what are the two stationary points here? Here the two stationary points are getting obtained in both of the cases. X is 5, right, because we have put x equals to 5 into equation 1, and by putting x equals to 5 into equation 1, what we have obtained the value of y? We have obtained y equals to 1 and y equals to minus 1, right? So this is the two stationary points. So we have obtained the stationary points. Now we are just going to put the stationary points. First stationary point was 6, 0, second was 4, 0, third was 5, 1, and fourth was 5, minus 1. Now what is r? As I have told you that I will told you about r, t and s in the later part of video. Now that later part has come. So basically r is fxx, t is fyy, s is fxy, and rt minus s square will be the calculation of it. Okay, so basically if we find out the value of if we put the value of fxx, that is 6, if we put the value of fyy, that is 6. Basically what we are doing here, let me tell it about it. So basically in the fxx, what was fxx? Fxx is nothing but let me show the derivative at first. Where is the derivative? Yes, this is fxx. So we are just putting the value of x and y in the equation. Y is not also present in the equation, but we are just going to put the value of x then. So if we put what is the point? First point is nothing but, first point is, let me see the first point. So the first point is 6, 0, right? So if I put 6, 0 in the, so here is 6 is denoting the x value and 0 is denoting the y value. So if I put 6 in place of x, so it will be 6 into 6, 36 minus 36. So it will be the value of fxx. The value of fxx will be, as you can see, it will be 6, right, as you can see. Similarly in place of fyy, we will find out fyy and we will put the values of x and y. Value of x will be 6 and value of y will be 0. Similarly in fxy, we will put the value of x and y, and by that, by calculating rt and s, we will find out the rt minus s square. Now as you can see, it is positive and r and t both are positive. So just see the conditions now. If rt minus s square is positive and r and t both are greater than 0 or positive, then we are getting minima. So this 36 is giving us what? This 36 is giving us minima. As you can see, this is the comment spelling is actually wrong here, whatever. Similarly you have to do it for all the points. In the second points, r and t both are negative and rt minus s square is positive, so it is giving us maxima. In the third point, r and t both are 0 equal to s is positive and rt minus s square is negative. So in this type of cases, when r and t are basically equal to 0 or r is positive, t is negative, in this type of scenarios, rt minus s square gives us saddle point. So basically this is a saddle point, and this is also the fourth point is also giving us the same thing, that is also the saddle point. So that's enough for today's video. If we want to calculate the maximum values, then the maximum values will be calculated from 4, 0 point, and the minimum values will be calculated from 6, 0 point. Okay, so if we want to calculate the maximum value, then in the main equation, on the actual equation, just put the values of 4 in place of x and 0 in place of y. Okay, so this is a way to calculate the maximum value, and you may want to calculate the minimum value also. Just put 6 in place of x and 0 in place of y to calculate the minimum value, because that is the minima So that is the stationary point that is giving us minimum. Thank you.